What if I told you that if you fell into a black hole, your friend watching from a safe distance would see you frozen in time, forever, just stuck there, like a cosmic pause button? But here's the twist. From your perspective, you'd sail right through. No freezing, no pausing. You'd keep falling, experiencing something so bizarre that physicists still argue about what happens next. Same event, two completely different realities. So, who's right? What actually happens when you fall into a black hole? Buckle up. This one gets weird. Look, black holes are probably the most terrifying things in the universe, and I don't say that lightly. We've got supernovas, gamma-ray bursts, rogue planets hurtling through space, but black holes? They're in a league of their own. They're regions where gravity is so intense that nothing, not light, not information, not your disappointed text to your ex, nothing escapes. And here's why this matters to you. There's a supermassive black hole at the center of our galaxy right now. It's called Sagittarius A star, and it's about 4 million times the mass of our sun. Don't worry, it's 26,000 light years away. We're safe. But what if we weren't? What if you somehow found yourself falling toward one? By the end of this video, you'll understand exactly what would happen to your body, your perception of time, and reality itself. And trust me, the answer is way stranger than any sci-fi movie has ever shown you. Okay, let's set the scene. You're an astronaut. Maybe you made a wrong turn. Maybe your spaceship ran out of fuel near a black hole. Doesn't matter. Point is, you're falling in, and there's no coming back. The first thing you need to know is the event horizon. Think of it like the point of no return. It's not a physical surface, you wouldn't feel anything crossing it. It's just the invisible line where the escape velocity exceeds the speed of light. Once you cross it, that's it. Game over. You're going to the center whether you like it or not. But here's where it gets crazy. The size of the black hole determines how you die. Wait, what? Yep. If you fall into a small black hole, say one that's only a few times the mass of our sun, you're going to experience something scientists lovingly call spaghettification. I wish I was making that up. Here's what happens. Gravity gets stronger the closer you are to the source, right? So if you're falling feet first, the gravity at your feet is significantly stronger than the gravity at your head. This difference? It stretches you, pulls you apart. Your body gets elongated like a noodle, thinner and thinner, until you're basically a stream of atoms being sucked into oblivion. You become cosmic spaghetti. Literally. Not a great way to go. But wait, there's a loophole. If you fall into a supermassive black hole, like the one at the center of our galaxy, the event horizon is so far from the center that the tidal forces at the surface are actually gentle. You could cross the event horizon and not even notice. No stretching, no spaghettification. You'd just drift across, completely unaware that you've just passed the point of no return. Quick question for you. If you had to fall into a black hole, which would you choose? Quick spaghettification or a slow descent into the unknown? Drop your answer in the comments. I'm genuinely curious. Okay, now let's talk about time. Because this is where black holes stop being just scary and start being philosophically terrifying. Let's say your friend is watching you fall from a safe distance. They've got a powerful telescope. They're tracking your descent. From their perspective, something strange starts happening. As you approach the event horizon, you appear to slow down. Not because you're actually slowing down, you're accelerating, actually, but because the light carrying your image is struggling to escape the intensifying gravity. You get dimmer, redder, slower, and right at the event horizon, you freeze, frozen, forever. To your friend, you never actually cross. You just hover there, getting dimmer and dimmer, stretched across the event horizon like a ghost, fading into darkness over millions of years. But here's the mind-bending part. From your perspective, nothing special happens at the event horizon. You sail right through. Time is moving normally for you. You might look at your watch and think, this isn't so bad. Same event, two completely different experiences. This isn't science fiction. This is Einstein's general relativity in action. Einstein himself was disturbed by black holes. When physicist Carl Schwarzschild first solved Einstein's equations and predicted these things in 1916, Einstein thought they were just mathematical curiosities, impossible in the real universe. But here we are. We photographed them. They're very, very real. Now, let me ask you something. If your friend sees you frozen forever, but you experience yourself falling through, which version is true? Both. That's the uncomfortable answer. Relativity tells us there's no universal now. Your experience is just as valid as your friend's. Reality depends on where you're standing. Stephen Hawking once said, "Black holes ain't as black as they are painted." He was hinting at something we'll get to in a moment. But first, what's inside the black hole? Okay, so you've crossed the event horizon. You're inside the black hole now. What's in there? Honestly, we don't know. And I don't mean we haven't figured it out yet. I mean our physics literally breaks down. At the center of every black hole is something called a singularity, a point where density becomes infinite and space-time curvature becomes infinite. Infinite. Not really big, actually infinite. And in physics, when your equations give you infinity, that usually means your equations are wrong. Here's where it gets really wild. Some physicists think the singularity might be a portal, a wormhole to another universe, or another part of our universe. Others think that inside a black hole, a whole new universe could be forming, that our Big Bang might have been the inside of a black hole in some other universe. Think about that. We might be living inside a black hole right now. I'll let that sink in. Still others, like Stephen Hawking, propose that information isn't destroyed in black holes. It's somehow encoded on the event horizon, like a hologram. This led to something called the holographic principle, which suggests that everything you experience in 3D space might actually be a projection from a 2D surface. Your entire life, everything you've touched, felt, loved, might be a hologram. Black holes didn't just break our understanding of gravity, they're forcing us to question the nature of reality itself. Let's get back to you. Still falling, still conscious, past the event horizon. What happens in your final moments? Well, if you're in a smaller black hole, you've already been spaghettified. You're done. A thin stream of particles spiraling toward the center. But in a supermassive black hole, you might have minutes, maybe even hours of subjective time, depending on the size. During this time, something incredible happens. You look forward toward the singularity, and you see the entire future of the universe playing out in fast forward. Every star that will ever be born, every galaxy that will ever form, the eventual heat death of the cosmos, all compressed into moments of your experience. You look backward toward the event horizon you just crossed, and you see the entire history of the universe stretched across the sky. You're literally watching time itself from outside normal causality. And then, you reach the singularity. Does time end? Does space end? Do you pop out in another universe? Are you encoded as information on some cosmic holographic screen? Nobody knows. And that's the honest truth. The laws of physics as we understand them simply cannot describe what happens at that point. And that's where our journey ends, not with an answer, but with the deepest mystery in physics. Black holes are more than cosmic vacuum cleaners. They're windows into the limits of human knowledge, and reminders that the universe doesn't owe us answers. If you made it this far, thank you for exploring this with me. Subscribe if you want more journeys into the unknown, and leave a comment with your thoughts on what you think happens at the singularity. Until next time, stay curious and never stop asking questions.